Hey guys, today we are going to be looking at how to make decisions with our confidence intervals that you will be starting to calculate next week. So make sure that you know how to interpret a confidence interval, you know what 95% confidence means, you also know how to find the structure of a confidence interval, meaning you know how to find the single value estimate and the margin of error from an interval, and the other way around, finding the interval when you're given a single value estimate and the margin of error. Okay, so this is kind of a throwback into what we learned at the very start of second semester in chapter 6 when we talked about the difference of two proportions. So right here, I set up a little table, just kind of what you might be familiar with when we did Unit 6, as well as when we did the percentage of success. So suppose we have the following question: do Derek Jeter's performances in 2010 provide convincing evidence that he had a greater true difference in proportion against right-handed pitchers than against left-handed pitchers? So a lot of the times, based on that question of interest, that's how we know how to subtract. So we think that he's going to do better against right-handed pitchers, so then you do right minus left. Okay, so then we would find our table and we put all our information in the table, and you'd find these numbers and you divide out of the total number of times at bat against a right-handed pitcher and times at bat against a left-handed pitcher. And you found some proportion, and you took that number and you subtracted it to find the difference. And that was your test statistic. So just to throw back on what our null hypothesis was, remember the null is a statement of no change. So we would say Derek Jeter had the same true proportion, or had the same true difference in proportion against both right-handed and left-handed pitchers. So I'm just going to use an RH for right-handed and left-handed pitchers. Now your alternative hypothesis is the statement of change. So we're testing that he had a greater true difference in proportion. So that would be our alternative. So Derek Jeter had a greater true difference in proportion against right-handed pitchers. Okay, and remember that alternative hypothesis comes from the question of interest and what we think that he does, who he thinks he does better against. All right, so I went ahead and I just typed out the null and the alternative that we just talked about up at the top. So the cool thing about confidence intervals is it's basically another way to form a conclusion. So hypothesis testing, it gives you evidence of one hypothesis or the other, and confidence intervals also tells us that. So with hypothesis testing, if your p-value was lower than the significance level, that means there was no evidence of random chance. So this would be an instance of statistical significance. So statistically significant. And what that meant, if you forgot, is we have evidence that Derek Jeter had a greater, missed that here, had a greater true proportion against right-handed pitchers. So it gave us evidence of the alternative that he had a greater true proportion against those right-handed pitchers. Okay, and if our p-value was bigger than the significance level, this means that we had a random chance. So we don't have statistical significance, so we would support the null hypothesis. So we have evidence that he has the same true proportion against both pitchers. So against both right-handed and left-handed pitchers. So what does it mean if he has the same true proportion? So if he has the same true proportion means if he bats, let's say, 3 out of 10 against right-handed pitchers, if he has the same true proportion, then he would bat 3 out of 10 against left-handed pitchers. So if we were to subtract those values, what would you get? 0. So if we claim that he has the same true proportion, that means that we would expect 0 to happen, and that supports the null hypothesis. So on the flip side, on confidence intervals, if I calculate a confidence interval that's entirely positive, so let's say it goes from 0.10 to 0.70. So this interval shows me that the lower boundary is positive and the upper boundary is positive. Meaning in this instance, we think that in every ounce of that interval that he did better against right-handed pitchers. So we think that he did greater completely against right-handed pitchers. So it's actually a very, very similar conclusion to what you would make if your p-value is lower than your significance level. So if we have an interval that's entirely positive, that means that we do have evidence of the alternative. We do have evidence that he has a greater true difference in proportion against right-handed pitchers than left-handed pitchers. So an entirely positive interval supports our alternative hypothesis. Now on the flip side, if I have an entirely negative hypothesis, so let's say I have negative 0.8 to negative 0.2, that would mean that he's not doing better against right-handed pitchers. And in fact, he's actually doing better against left-handed pitchers, because if we're doing right-handed pitchers minus left-handed pitchers, then in every instance, you would have this value, this left-handed pitcher's value, being higher than the right-handed pitcher's value. So therefore, this would actually give us evidence for a lesser true proportion against right-handed pitchers, or we could also say on the flip side, a greater true proportion against left-handed pitchers. Sorry, I had to pause the video. My dogs were getting rowdy, fighting with a toy. So if the 95% confidence interval contains 0, okay, so if our 95% confidence interval contains 0, meaning it goes from a negative value, so like negative 0.17 to positive 0.32, that means that within that interval, the value 0 exists. Well, what happens if the value 0 exists? That means that in some case we think that it's possible that they could have the same true difference in proportion, which links directly up to what we talked about when we said that if your p-value was greater than the significance level, this means that we have evidence that they have the same, so evidence of the null. So anytime that you have a negative to a positive, that means your interval contains 0. So you do not have evidence of a change, so you do not have evidence of a greater or a lesser true proportion. Hope you can read that, sorry. Okay, so this is actually the confidence interval that we calculated for Derek Jeter's performance. So a 95% confidence interval for Derek Jeter's difference in proportion is from 0.043 to 0.217. So what do you see about this interval? Is it entirely positive? Is it negative? Does it contain 0? I see 2 positive values. So that means because my interval is entirely positive, I have evidence that Derek Jeter has a greater true difference in proportion against right-handed pitchers. All right, so here's a new scenario instead of Derek Jeter. So in 2009-2010 regular season, Kevin Durant of the Oklahoma City Thunder led the NBA in scoring with 30 points per game. At home, he was 31 points per game, and he averaged a difference of 29.2 points per game. So we think that's what his single value estimate is, because that is the true difference in means. So, but then when we calculate our confidence interval, which again, you will learn how to do, We state that a 95% confidence interval for the difference in his true mean at home and away is from negative 1.1, well, I don't know where that comma came from, negative 1.1 to 4.8. So when I'm actually deciding if I have evidence that he has a greater ability or a greater true mean, because we're trying to be a little bit more advanced with our language now, is I look for the interval, I see it goes from negative to positive, which means what value does it have in the middle of it? 0. So because the interval contains 0, I do not have evidence of a greater true mean at home and on the road. So make sure that you are still including your context when you're answering these type of questions. Context meaning we're talking about Kevin Durant, or are we talking about Derek Jeter? And what about those guys are we actually talking about? Points scored, the proportion of hits. Make sure that you're including that when you're making a decision. So this slide is probably the most important slide of this lesson. So this is the general idea. So if your confidence interval does not have 0 in it and is positive, there is convincing evidence of a greater true parameter in context. So that also is dependent on the question of interest. So if I'm talking about him having a greater true mean to take a test on a computer versus on paper, then I expect positive interval if he's doing better on a computer. Whereas if I was talking about him doing better on a computer, but then I get negative interval, that means I would have evidence that he did not as well on a computer, or he did better on paper. So if your confidence interval does contain 0, meaning it goes from a negative value to a positive value, that means there is no difference in the true parameter. So this conclusion up here supports whatever our alternative hypothesis is, whereas this one will support whatever our null hypothesis is. Now you won't be necessarily writing an alternative and a null, but if we're talking about a change happens if I have an entirely positive or an entirely negative interval, whereas there is no change because of that big 0, which supports the null hypothesis.